Hello everybody, welcome to my channel. So in this video I'm going to talk about the model 3, which is the classification algorithm, and also it works as a regression algorithm, and this is none other than the KNN, which is really famous, easy to understand, and a lot of people understand it because it is really that simple kind of algorithm. So in order to understand the full grasp of it, you need to watch my previous two videos where I talked about a lot of basic stuffs, and where I talked about the logistic regression algorithm, which is again also a classification algorithm that works on sigmoid function and some probability matrices, and I have implemented all the code using the Python and pandas. Similarly, in the first section of the machine learning series, we already talked about the most easiest one. The easiest one is the linear regression, and this is not a simple linear regression. It was a multivariate linear regression that I talked about, and I also implemented it using the Python and pandas. And learn everything using the pandas, how we can manipulate columns, rows, add new column, add new rows, and just filter them out, sort them out, and just data cleaning, data pre-processing, all the thing in order to fit all the training data sets into your machine learning model. So all of those things are already I discussed about in this previous two videos. So today's videos is especially on KNN. Okay, so what are the main concept of KNN? KNN is one of the most easiest machine learning algorithm that you can ever understand. This is really simple, and most people really understand it, and it really works well for the small data set. If you have large data set, it might have some problem with it, because it needs to calculate all the distances. It actually works based on the distances, like Euclidean distance, Manhattan distance, which I'm going to talk about it a little bit later. Secondly, it can be used as classification and regression problem. As you know, the regression problem, if you watch my previous video, you already understand the regression problem basically is it is a numerical analysis based on some parameters. You want to predict something, and in those predictions we need mathematical models, and we need mathematical data like feature data and the target class. We need to predict the target values based on our feature vectors. Okay, so this is the regression model. But in classification, you need to classify. There is a label. If you are in this particular class, if you have this cancer or not, if you have heart disease or not, if it is a email fraud or not, is it a scam or not a scam, it can be different kinds of label. You need to predict that, you need to identify that, you need to classify that. Like similarly, in the right hand side, as you can see, we have a dog. Okay, so if you see the triangle, green triangle, it is a dog classification, suppose here, and the red circle that you see is a cat. Okay, so you need to, based on some parameters of the x-axis or the training data set, you need to classify, is it a dog or a cat. And the star, as you see, for differentiating, I'm using this sign for a star so that you can identify this is a test data. So the KNN is a very simple algorithm that it can classify your desired output based on some distance matrix, distance calculation. The closer you are to me, I will vote for you. Okay, it's also based on voting. Suppose I take 5 elements and 3 of them is supporting me, they are closer to me, then it is my I'm based on this class. Okay, so it works based on voting. As you see, this is the orange circle. If you just zoom in a little bit, the red, as you see, red circle, this is a cat class, and the green rectangles, these are dog classes. So if you take 3 of the values, you need to take 3 values, 5 values, or 1 values. It should be odd values, not even, because for voting it should be 1, 3, 5, or 7. It works like that. Okay, you need to take always odd numbers. So 2 of the values are in the dog classes. So in the this is our test data, this is the black star is our test data, and if we measure the distance between those things, the closer of the 2 values are the green, these dog classes. Okay, so if you measure the distance, this one and this one, the 2 of the values are voted for the dog and 1 value is voted for the cat. So we take the majority of the vote. So it should be, there are 2 dogs and 1 cat. So this should be, this new data point star should be based on the classification of the dog class, because it has 2 points for the dog and 1 points for the cat. We take the vote. And there is some really good news for the KNN, that it has less sensitive to outliers. Outliers is that one number is very high, suppose here, and these are called the outliers. We will talk about briefly later. And less sensitive to outliers, and predictions are based on majority of the class, and we know it as voting, which I already talked about. And the best and the very good thing about the KNN, that it doesn't generalize a global model from entire dataset. It doesn't generalize. In other models, what it does is it generalizes every single data from the training data set, what we feed into it, it just generalizes a particular pattern. Based on this, it predicts. But in that case, it doesn't work like that. It works on the test data sets mainly. The accuracy is tested on the test data set, not only training. Okay, in the training, we just feeding into it, and it also doesn't make a generalized model based on it. Okay, so that's why the accuracy would be better. Okay, it just works based on the distances. How close the distance are, I will identify the class into that class. Okay, so that is how it works. And it doesn't have a training phase, it doesn't learn, so it's a lazy learner. That's why the KNN is also called a lazy learner, because it doesn't have a training phase. Predictions are made on the time of testing, that I already talked about. Predictions are made on the time of testing, not on the training. When you test it, then it makes some predictions, not earlier. So that's why it calls a lazy learner. So for KNN matrices, these are the things that we change to make sure these are the way we find the distances between the 2 points. These are called the KNN matrices, and there are 3 matrices. Euclidean, which is the most famous, that calculates the distance between 2 coordinate points of x and y points, and this is the formula for it. And for Manhattan, it is more simpler. It is just like a geometric difference between 2 points. Minkowski, which is another matrices, and it is a combination of Euclidean and Manhattan distances, so it just measures differently. Okay, Minkowski is a combination of Euclidean and Manhattan. If you take the value of q is equals to 2, then it becomes Euclidean. On the other hand, if you take the value of q is equals to 1, then it's simply just similar as Manhattan. It's nothing other than Manhattan. If the value of q is 2, again it should be Euclidean. If the value of q is equals to 1, it is Manhattan. This is only the simple idea. Okay, so we'll talk briefly about it. So k values, the optimization technique for the KNN is the k values. K has a significant role in optimizing the KNN algorithm. So all it does, this is the main parameter of this KNN algorithm. So k has a significant role in optimizing the KNN algorithm, as it has a value like k. It means that the model is overfitted for training dataset. It's so easy. When it's so easy to classify, you have only one cluster, or k is equals to 1, you have one neighbor, then it doesn't do well. So that's the problem where the overfitting problem comes out, because your model is complex but your training dataset is very simple, so it gets overfitted. But if suppose your k value is 13 or higher, 15, 17, okay, then it becomes sometimes it becomes a problem of underfitting problem that happens in the datasets. So you have to make sure that the k value is very suitable for your dataset. Okay, it should be like, based on your dataset, it should be around 3, 5, 7, 11. Maximum case it should be 11. Most of the cases it works really fine, but for a small dataset, the k value is 3, 5 will do the job done. Okay, so most of the cases we just tweak these parameters to get the highest optimization possible. Even in the code you will see I will just change it differently, and I will use the automated system so that I can just get everything right. Okay, so let's talk about the distances. Okay, so this is really important to understand the distances, and let me just draw something. Okay, so suppose I have a point, so this is one point, this is another point. I need to find out the distances. Suppose this is 2 and 4. Suppose this is 2 and 4, and this is 6 and 8. Okay, so how we find the Euclidean distance? So in the Euclidean distance, it should be, if I just write it correctly, in Euclidean distance, it should be this point. This is x1 point, this is y1 point, this is x2 point, this is y2 point. So distance between these 2 points. Okay, the distance between these 2 points, how we calculate it? You just calculate the square root of it, and you will get the value of x1 minus, so it should be x1 minus x2 plus whole square, and you need to use plus, and y1 minus y2 whole square. This is very simple, just x1 minus xi whole square up to 1 up to k. It means that the number of values you have in your dataset, it can be up to 1 to 100, 1 to 200. You need to do it by yourself. Okay, so this is the main formula that you have. So in our documentation, the Manhattan distance is xi minus yi, and this is our Minkowski. Here the q value is the ultimate differentiating factor, but if you want to do it for Manhattan distance, this is for Euclidean. For Manhattan, I'm drawing it again. Suppose we have two different points. Suppose these 2 points, okay, these 2 points, and now I want to find the distance between those 2 points. So how can we do that? We need to go to the x-axis. Suppose we are going to the x-axis, then we need to go to the y-axis, go along to the x-axis for some time, up to this point, and then we need to go to the y-axis for some times, and finally we are getting the distance. Okay, so this is amazing how we can do this. And the formula is similarly xi minus yi. I need to use modulus, and there is no square because the square is on the Euclidean distance, but on the Manhattan distance you don't need to use this thing. And this will happen up to n is equals to 1 up to k. How many number of data set you have? Suppose 1 up to 100 points. You need to do the same thing. So this is the same logic here. And for Minkowski it is similar. Let me write it for Minkowski. It should be xi minus yi point, and then we have n to the power q, and then we have 1 by q. So this is for the Minkowski. And if the value is q is equals to 1, suppose q is equals to 1, then it becomes this one, Manhattan distance. If the value is 2, then as you can see, there is a square there, then it becomes Euclidean distance. And 1 by q is nothing but square root. Similar. So all of the things are basically same thing, but the Manhattan distance is the geometrical distance. You need to go along x-axis and then you need to go along y-axis to get that particular point. So it works in the electrical circuit, on city diagram, city blocks, all of these things. This is the Manhattan distance, and this is the point, and the coordinate point connection is actually the Euclidean distance. This is how it measures the distance between these 2 points. This is nothing fancy. This is very simple stuff. So if you want to see this in a big pictures, as you can see, this is how it works. Okay, so if you take a measure like this, if you take the star here, if I take another star, so let me take it. If I take a star here and if I just make it black, then as you can see, if I take this thing and copy and pasted this stuff, okay, so now I have taken 5 cluster, 5 k-nearest neighbor. Okay, k value is equals to 5. I have 3 cat values, 3 classes of the cat data points, and the 2 classes which belong to the dog classes. Now 3 is greater than 2 with the voting. In terms of voting, the cat own, so our new data point is very close to the cat data set, so it should be classified as cat. Okay, so as you can see, if I take the value 5, it becomes different, but when you take the value 3, it becomes different. So based on the k value, it will be different. Okay, so based on the k value, but when in this case, when you take the k value is equals to 3, then it becomes dog. Okay, so based on the k value, it is really important. It changes everything. The output becomes different based on the k value. So to identify the perfect k values is super important and is the vital thing here. Now if you come to the Scikit Learn k-nearest neighbor classifier, here you'll see the most important parameters is the k is equals to 5, 6, 7, 5, 7, 11. You need to tweak this out to get the optimized output, as you already know about it. So this is the first parameter. How many neighbors you want? Do you want k value is equals to 3, 5, 7, 11, whatever? Okay. And I also show you in the code how you can get the optimized value for the k, which is the main important thing in this particular algorithm. And they also talk about weight. It has distance weight and uniform weight. By default, it will take uniform. So what it does, the uniform weight, all points in each neighbors are weighted equally. So the weight is equal for all the neighbors. But for distance, it does the inverse of their distance. In this case, the closest neighbors of a query point will have a greater influence. So it works based on distance. So there are different weights based on it, and there are some algorithm like by default it will take the algorithm as auto, and it has other algorithm like ball tree, KD tree, brute force. So in the math intuition of this algorithm, behind the scene they are working on different kind of algorithm to solve this KNN problem. in the Scikit Learn. So these are the technology that you're gonna use. These are the algorithm that they're gonna use. But default it is set to auto. Ball tree, you can see, check the ball tree, how it looks. You can see the KD tree. It is like a tree like data structure they use. And the brute force will use brute force search. So if you just understand all of this stuff properly, you will make a really good KNN algorithm. So this is very important to understand. And then we have the leaf size. Leaf size is actually how many leaf you have in your tree. So you need to understand the tree data structure. That's why I'm not making this so much super complicated for you. So if you understand the tree data structure and it has nodes, it has leaves, all of this stuff, then it would be really easy for you to understand. As you can see, it says leaf size passed to the ball tree or the KD tree, how many leaves you want in your ball tree or KD tree, and this can affect the speed of your construction and query. If you have tons of leaves in your tree, then it will take a lot of time to just process all these informations, because it works on the distances. So the optimal value based on the natural problem. So it is really important. And then we have the matrices. It by default it use Minkowski that I already talked about, but you can just add it dynamically by yourself. You can just in the parameter you can just use neighbors or Euclidean distance or Manhattan distance. You can figure it out there. You can use matrix as like Euclidean and Manhattan instead of Minkowski, but by default they use Minkowski technique. So these are the type of features and feature names. All of the stuff is very common, but the most important thing that which kind of algorithm that you're gonna work on, and your neighbors, k-nearest neighbors, and your matrix can be different, like Euclidean distance or Manhattan distance. Based on it, you just change all those parameters and get your desired output. Now I'm gonna do it in a code implementation so that you can get the full grasp of it in real life, how we implement this using the Python and pandas, which are really important for you to do any kinds of machine learning work. So let's dive into it. Let's get started. Let's do the Python code. So open terminal and we're gonna open Jupyter Notebook. Okay, so now we are going into the Python Jupyter shell and we're gonna create a new project, and it should be called as KNN image classifier. Because this is a classifying algorithm basically, and this is for YouTube. Okay, so KNN image classifier YT. So here we're gonna import pandas as PD, and we're gonna import some other thing like the image dataset. So as you can see, Scikit Learn dataset load digits. So here we're going to use the image dataset from the Scikit Learn. So we're going to import this from Scikit Learn dot datasets import load image. So they have a lot of custom datasets that is completely built into their libraries. You can just import load digits. Okay, so these are the digits that you have. Like if I just go 0, 1, 2, 3, these are all the training dataset, and these are the predictions, and these are the digits. If it is like that, it is 0. If it is like that, it is 1, 2, or 3, so forth and so forth. Okay, so this is pretty simple thing. We're gonna import this stuff. Now we're gonna run this. Okay, so let's do this. Digits is equals to load digits. Okay, here I'm gonna print this stuff. As you can see, it has a lot of stuff. First is the data sets. Okay, all the data sets. Then we have the target set, and this is the target, like if it is a 0 or it is a 1, it is 2 or 3. So these are the 0 up to 9. These are your data sets. These would be your predictions. Based on this data, your targeted predicted classifier would be, is it a 0 number or 1 number, 2 or 9. These are the target digits that you're gonna predict. Okay, so this should be your Y, and these are the features. So based on those features, you're gonna have this thing. And you can also just print these images and see these images, and these are the target names, like 0, 1 to up to 9. These are your target names. Okay, so you're gonna use all of this stuff here. So we need to access like feature name, frame, features, and target and data, all of this stuff. So first what we can check, digits dot feature name. Okay, so these are your input features, and also you can also see the data. It should be digits dot data. Okay, so these are the array of data, and we also have the data sets for target name. So this would be a target name up to 0 to 9. So these are your main digits that you're going to use. For this would be useful for your target column. Okay, so there are other stuff. We can just rename it to data frame df is equals to pd, which is pandas dot data frame. I'm going to put all the data into pandas data frame, and this should be the data set of digits dot data, and we should have a columns, and column should be digits dot feature names. This should be your columns, the column name. Okay, feature names are the column names, and you can just print this stuff. As you can see, these are your feature names are your column names, and as you can see, there is a lot of columns. As you can see, 64 columns and this amount of rows, and we don't have a y column, which is our classification, which is our resultant column that we want to predict. So we need to get that thing. So how can we do that? We can just add a new column using the target. We just name it target, and how we can get it, we should go to digits dataset, and here we're gonna get the target. Okay, and now we can get this assigned into our dataset. So if we just print it, now as you can see, we have a new column called target. As you can see, we have added a new column with the digits target dataset, and target are the value like based on these features. Is it 0 digit or 1 digit or 2 digit? These are different kind of thing. We have total 9 type of digits, target digits. Okay, so that's beautiful. And if you want to check it, df dot target, if we go to target is equals to 1, so how many 1 digits are there? You will just see this dot head like 10. If I print this, it will show you like 1, 11, 21. These are the indexes value, which is predicted as 1. So you have different kind of thing. For 2, it will be different. If I just print this, see, it is different indexes which are predicted as 2. So it's completely fine. The data set is really awesome. Now I need to import some very important stuffs. So from Scikit Learn dot model selection, we're gonna import train test split into split the training data and the test data. As we know, this is really important. We need to use grid search CV, and which we also know as grid search cross validation, and random search CV, which is randomized search cross validation. That is the play. This is the thing that will be really useful to find out the actual k value, how many neighbors or the k values we should use. Is it we should use k is equals to 3 or 5 or 7 or 11, which is the value that will give us the optimum output, optimum result based on data set. It will just do it automatically for us. It will calculate everything, the best possible values of the k. It will just find out everything for us. Okay, so this is really powerful. And then we need other thing, or Scikit Learn dot neighbors, Scikit Learn dot neighbors, import k nearest neighbors, k nearest classified. This is our main model. And then we need other stuffs like some metrics stuff to measure the accuracy. So Scikit Learn dot metrics. Okay, we can import confusion metrics. If you don't understand the confusion matrix, I will make a dedicated video on it. Just make sure you understand make sure the confusion matrix is really useful to measure the accuracy of your model. Okay, like decision tree, algorithm, random forest, support vector machine, all the things use confusion matrix to measure how well the model is performing. Okay, so I'll talk about it briefly in the second part of the video. Okay, so I'll talk about briefly later about it. Okay, and we need the classification report. Okay, it will give you also a report that how well your model performed with the different kind of parameters. Okay, so this is also really useful thing. And then after importing all of this stuff, we need to classify our x value. X value is data frame dot drop. We need to drop which column is our target column. We need to drop because we don't want it in our feature or feature variables. Okay, and make sure we just need axis is equals to 1. If you want to delete a particular or drop a particular, if you want to delete or drop a particular column here like this, you need to use axis is equals to 1. If you want to drop a row, you need to use 0. So here I'm dropping a column called target in the x variable, so I have to do this. So in the y, we need to use df target. So this is the target variable or target column is our y. This is our predicted column, and this is our feature column, which we don't want the target. Okay, so if I just do this, if I just print x, you'll see there is no y column here. Okay, so this is working perfectly. Now we need to split it. X train, x test data, and train data, we are splitting it, y train and the y test. It should be a small letter, and it should be coming from train test split. We're gonna split it with x and y that we defined. We separated our feature and the target, and we need to set a test size of 0.2. This is a simple test, like 20% of our data should be inside test and 80% of the data should be in the training. And we can use one more parameter, random state, suppose 1. Okay, then we can print like x test data. See, these are the data, like 360 rows, and these are the rows, amount of rows we have for the test. And if I just print the train, and see 1400 rows are for training. So these are the things that we feed into our model, and x test is for testing our model. So these are really simple, we don't need to understand it that much. Then we can use KNN is equals to k nearest neighbor. This is our classifier, and we're gonna just predict a simple n neighbors. See, n neighbor, this is the optimal parameter. Suppose how this is a very important parameter, hyperparameter, how many neighbors you want. Suppose I want 3 for default. Okay, so now we need to feed the model our data, x train and y train. Okay, make sure it is a train data, not test. So for feeding we need to use the data. Now it is trained. Now we can use this thing, ypred is equals to knn.predict. This is the method, and we're going to pass the x test data so that we can test the actual accuracy of our model based on this x test data that the model never seen. So that's why we are using test data to see how well it performed. So it should be y_pred, and this is the prediction value. So how we measure the score or accuracy? So you can use how can you measure the score, how well it performs? So knn.score method gives you all the options. Like here we pass x_test data and the y_test data. Okay, so you pass x test data and y test data, and just check how it performs. So as you can see, it performs really well, 0.994% accuracy. Now if you just change the value to 5, okay, so let's check it out. So this is the only hyperparameter optimization that we can currently have. So I changed the neighbors to 5, and then we're gonna run all of this again. And as you can see, the performance is pretty good still. If I change it to 11, so these are the 11 neighbors we are using. And now as you can see, the performance is degrading. Before it was 994, now it is 991. So based on this parameter, your optimization would be different, your accuracy of the model would be completely different. Now how we understand it is better or not? Okay, so this is the thing why you need to use some parameters, some use cases, how we can do this stuff. Okay, so after the split of this data, so after that we're gonna use some stuff here. We're gonna use grid search cross validation. Using the grid search validation, we're gonna validate what should be the best accuracy score for the neighbors. Is it 5, is it 3, is it 7 or 11? It will find it automatically for us. So here we're gonna use Scikit Learn model grid search SB. Okay, so this is the thing that we're gonna use, and we're gonna use different variables. First is the parameters, params. So these are the things that we're gonna use, and let's check it out. Yeah, you need to pass all the params. The params should be like n neighbors. N neighbors should be different. You can use range in Python, range 1 up to 11. Okay, so it will test up to 1 up to 11 with different kind of value. It will iterate over it and check which is the best accuracy it can give. And metric, as you already know by the theory, it uses Euclidean method. So here we're going to use Euclidean and Manhattan. These are the two type of metrics that we have to identify or calculate the distance between two different points. As we already talked about, the Euclidean is really important, and CV is the cross validation. You can use different kind of thing, but I think this params works really well. And now we're gonna use the grid search. Here we're gonna use the grid search CV. Here we're gonna pass the KNN model, and before that we need to add one more thing, this line. Okay, we need to import our model, and we don't pass anything, we just keep it empty here. And we're gonna pass the KNN and the params grid. Params grid is equals to params, and we're going to use cross validation is equals to 5. Okay, you can change this variable cross validation 7, 8 or 9. I'm just checking with 5. Okay, and then we're going to use grid search dot fit. Okay, and we're going to fit this x train and y train value. This is super important, and make sure its variable name is perfectly done. We need to fit it. So this should be our params, this is our KNN, this should be grid.fit. And now it's time to use the best fit for the grid search. It should be grid search dot best estimator. So this is the thing we need, the best fit search. As you can see, when it uses the matrix Euclidean and n neighbors is equals to 1, we have 1 neighbors, then it performs better. So this is really funny. Okay, so it tested with different kind of parameter like neighbor 1, 2, 3, 4, and it finds that when you use n neighbors is equals to 1, it gives the best accuracy. So if I delete this and add n neighbors is equals to 1, so that's only for this value we need to use this kind of code, all this code grid search CV, so that it can perform all the thing by itself, given the value like neighbors up to 1 to 11, and check in which method it performs better. Okay, so that's why the grid search CV is super useful. For many algorithm you must use this thing. Okay. So it's done, and now we're gonna check the accuracy. Now as you can see, the accuracy is pretty good, but we already tweaked it with different value. It performed differently. Now you need to just check the KNN, the accuracy, the confusion matrix. Confusion, you will understand it better. Like confusion matrix, you're gonna pass y underscore test, comma y underscore predict. So we're gonna pass the predicted value and the y test value, and we're gonna print confusion matrix. So these are the confusion matrix, and we're gonna print one more thing, which is classification report, and here also we're gonna pass these values. Okay, now as you can see, its performance is really good for zero digit prediction is precision recall. F1 score is how good your model is. Recall is also almost the same, precision is almost the same, but little bit of equation difference, but it performs really well. Only slight difference only here in identifying the 3 digit, it has some problem. It is a minor problem, you don't need to worry about it. It's really powerful. It's working really nice. And as you can see, confusion matrix, all the thing is really working perfectly. Every value is 0 here, and it can predict this properly. The only problem is that only this fourth column we have 41. It had some problem. As you can see, it had some problem with identifying it. That's why it is 0.99. And we have two problem in this 33. As you can see, it has some problem. Okay, so 1 and 1, so these are the errors. So if it is all the 0, only one value is there, it is very good. If there is any one other values other than this numeric value 1 or any other, then there is some problem. Okay, so almost it is working really fine. As you can see, all the values are 0 in this column, all the values are 0, all the values are 0, so it is working really fine. For 41 it's had some problem, as you can see it had some problem, and for 30 it had some problem. Okay, so every other values are really working fine. So you have one more classification system. After that, here we're gonna add one more thing, and here we're gonna use random search CV, and here also you're gonna use this kind of params. Okay, here also this is params for random CV. Okay, so from scipy.states. Scipy.states is another very important module or library for machine learning and for data analysis. For here I'm going to import the random integer, and here I'm going to put the param distribution. Just name it param distribution. So n neighbors we're going to use the rand integer. Okay, here we're going to pass 1 up to 11, and here same for the matrix we're going to use the Euclidean in Manhattan. Okay, so these are the param distribution, and here I'm gonna random search. Here we're gonna use random search CV. Here we're gonna pass the KNN. So before that we need to just import the KNN. Here we don't need to pass anything because we are just finding the optimizer for this. So this is the params, so we need to import it. And in randomized search CV we need to pass the KNN again. If I zoom in, you'll see it properly. And here it also takes the params. Param distributions is param dist. These are the parameter we're gonna use, and we're gonna use some other parameter called an iteration. How many iterations you want to do with this, for how many times, for 10 iterations. And cross validation you're gonna use value 5. You can tweak these values and get your optimized performance. Okay, so this is the thing that I'm going to showing, that how you can optimize your performance using the random search, cross validation, and your grid search validation. Okay, so these are for especially for validation. So after that we're going to use after this cell you can add one more random search dot fit the model, and xtrain and whiten you need to fit it again. After you fit it you're gonna get the accuracy. Okay, so it is fitting it properly. Then you're gonna best estimator, you're gonna find for random search dot best estimator, and you're gonna print best estimator, and it is working fine. Let me do this. It's really working. Matrix rand int scipy.states rand integer, and let me check. Let me change it to param distribution is equal to param distribution, and iterations 10, and we're gonna fit it, and now it works. So there's some problem with this parameter. So now as you can see, the n neighbors is equal to 3. When you take 3 neighbors, it gives the best optimal output and the best accuracy possible. And then we're going to change it to 3, and let's check it out if it improves or not. As you can see, it improved significantly. Before that it was 0.991, now it is 994. So it is performing really well, and the confusion matrix also really accurate. As you can see, there is lot less 1 here. Up to this there is no 1 value, only the numeric value, which is the actual prediction. So it is working really fine. Only some problem with 34 identify. Okay, so it has some problem with identifying 34. That's why it's 0.96. Otherwise it's really great. Its performance is awesome. Yeah, so this is the thing how you can find this is how you can fine tune the KNN, the k-near sniper, which is really awesome algorithm. But the problem is that it can't handle huge data sets because you need to calculate the distance from different points, and if you have a large amount of if you have a very big outliers, it will also predict it very wrongly. So that would not be the best solution. If the data set is very large, or if you cannot estimate the k value properly, or if you find any outliers, then it would be really hard for you to get the proper accuracy. So these are all the techniques that I have used, especially so that you can fine-tune your algorithm properly for not only for KNN, for any other machine learning algorithm. It can be for random forest, decision tree, which are really powerful, support vector machine, which I'm going to talk about the next video. So these are all the really powerful things that you can do, and that's why it's really important to show you how the grid search CB and the random search CB works and how you can tweak it. So till then, take care, bye bye. I'll see you in the next video with more awesome and beautiful video for this support vector machine. Just wait, and I'm making a very good video on support vector machine, because the next video would be really bombastic, and I will make sure that you will understand every single thing of support vector machine as well as other machine learning algorithm in general. So till then, take care, bye bye. See you in the next video.